As I was just telling you yesterday, we have to start what what we call as solving the Legendre's equations. Okay, and a typical Legendre equation is something like 1 minus x squared y double dash minus 2xy dash plus alpha into alpha plus 1y equal to 0, where alpha is strictly greater than minus 1. Okay, this differential equation is called as a Legendre's differential equation of order alpha. Okay, now as I discussed yesterday only, we know that the only singular points are x equal to plus minus 1 for this differential equation, and therefore we can say that y equal to x equal to 0 is an ordinary point, and therefore I can talk of a power series solution of something like this. Now see, I am changing a little thing here in the sense that instead of writing cnxn, I am writing cmxm. That's because as we move on, you will realize that n has a different role to play here. Okay, so we are starting with the power series of the form y equal to summation cmxm, and because x equal to 0 is an ordinary point, so this will be a convergent power series solution for the Legendre's differential equation. Okay, now, if I start with this as y, now my y dash, girls, what I would like is you write it in your notebooks, because this derivation is not there in the book. Okay, so your y dash will be m equal to 1 to infinity m cm x minus 1, and y double dash will be m minus 1 cm x m minus 2 m from 2 to infinity. Is this okay? I mean, so far so good. Okay, now I mean, of course we are not doing anything new right now. We're just following the procedure that we have learned so far. So we'll substitute in the differential equation, and we are going to get 1 minus x squared. So this would imply 1 minus x squared summation, sorry, it was y double dash, so it will be m minus 1 cm x m minus 2 m from 2 to infinity, right? And the next term was minus 2xy dash, right? So it will be minus 2x summation m from 1 to infinity m cm x m minus 1 plus alpha into alpha plus 1y. So y would be simply summation cm xm m from 0 to infinity equal to 0. Is this okay? Huh?
Yes, ma'am.
So now we can just, split the terms, and the first term will still be this m from 2 to infinity, because it is 1 minus x squared. But the second term will become minus summation m from 2 to infinity m minus 1. Now it is x m minus 2 and x square, so it will be simply xm, right? Similarly, the third term will be simply minus 2 summation m cm xm m from 1 to infinity plus alpha plus 1 summation cm xm m from 0 to infinity equal to 0. Now, as I always say, we have to see xm everywhere. Okay. Now, but then first we have to see xm, and then we have to see the starting point for the summations, right? So in this case, my starting point is 0, right? But in this term, my starting point is 1. So I just have to see whether m equal to 0 will change this series or not. If it does not change, I can change directly my starting point from 0 to infinity. Similarly here also, though it is, I have x to the power m, but starting point is 2. So I just have to check whether m equal to 0 and m equal to 1, whether it will change the series or not. If not, we can directly change the starting point, right? But here we have xm minus 2. So definitely we need to change. That means in this term, I definitely need to change my m to m plus 2, and automatically my starting point will get changed. So I don't have to do anything with the starting point here, right? So if I observe, see, m equal to 0 will not change this series, m equal to 0, m equal to 1, because of m and m minus 1 here will not change the series at all. Okay, so directly I can say, I mean, after changing the first term and the starting points in the other terms, my differential equation now becomes, I can write it as summation m from 0 to infinity. Now I've changed m to m plus 2, so it will become m plus 2, m plus 1, c m plus 2 xm, right? Minus 2. Now I just have to change the starting point. Nothing is going to change. Okay, so it will be simply m minus 1 cm xm, right? यही आएगा ना? I hope.
मैम 2 नहीं होगा।
Coefficient 2 is not there.
Yeah. M minus 1 xm. 2 is not there. 2 will be there in the next term, right? Then the next term will now become minus 2 summation m from 0 to infinity m cm xm. Is that right? And the last term will be alpha plus 1 summation m from 0 to infinity cm xm equal to 0. Is this right? Now we can combine all the terms. So I just have one summation from 0 to infinity with x to the power m common, and I am left with, now you can see, m plus 2, m plus 1, cm plus 2 minus. Now see, I have all these three terms with cm, right? So I can take cm common from there. Minus cm I have taken common. So it will be m minus 1 plus 2m minus alpha into alpha plus 1. This bracket and then this bracket equated to 0. Is this okay? कोई गलती तो नहीं है? Sure, है ना? That means I now have summation m from 0 to infinity xm. The first term I am not changing, m plus 2, m plus 1, c m plus 2 minus cm into. Now see, I'm just expanding these terms. It will be m square minus m plus 2m minus alpha square minus alpha equal to 0. Is this okay?
Yes, ma'am.
ठीक है ना? That means इसमें कोई just cross check, because हो सकता है I can commit a mistake, so please do it carefully, and then if I'm wrong, please point me out. Okay, so that means now I have m from 0 to infinity, again xm common. I have m plus 1, m plus 2, cm plus 2 minus cm. Now just look at these terms. It's now m square plus m minus alpha square minus alpha equal to 0.
Ma'am, I think it is minus m.
No, it was plus 2m, na? Minus m plus 2m.
Okay, okay, ma'am. Okay.
ठीक है ना?
Yes, ma'am. Yes,
So
ma'am. Yes, ma'am.
m square plus m minus alpha square minus alpha equal to 0, right? Now just look at this term. Can I not write it as m square minus alpha square plus m minus alpha? Right?
Yes,
Which
ma'am.
is nothing but m minus alpha, m plus alpha, plus m minus alpha, which is nothing but m minus alpha common and then m plus alpha plus 1. Am I right?
Yes, ma'am.
Yes,
So
ma'am.
that means my term, my equation is now actually this: m plus 1, m plus 2, c m plus 2 minus m minus alpha, m plus alpha plus 1 cm equal to 0. I mean, in a simplified form. Isn't it this? Right? So now since the coefficient must be 0, so using what we have done earlier also, I can directly write my cm plus 2 now. So my cm plus 2 is actually nothing but m minus alpha, m plus alpha plus 1 upon m plus 1, m plus 2 into cm. यही हो गया ना?
Yes, ma'am.
Right. Now see, how are we going to get the coefficients? By giving different values to 0, or by giving different values to m, right? Now, if I give, see, my alpha is a constant. I mean, it will depend upon the order of the equation, right? But it's any term greater than -1. So I have to retain my alpha as it is. So it's just that when I give different values to m, I'm going to get different coefficients here, right, in this expression. So to simplify, I mean, if I put m equal to 0, it's going to be minus alpha. When I put m equal to 1, it's going to be 1 minus alpha. So since because of that, so what some authors do is they can write it like this. It is not going to change anything, but it's going to give uniformity to the coefficients when we find them later on. Nothing else. Okay. Now we'll put different values to m and then see how the coefficients behave. Okay. So when m is 0, you're going to get C2, and C2 is going to be minus alpha into, see, m is 0. So it's going to be alpha plus 1 upon 1 into 2 C0. Am I right?
Yes, ma'am.
Right. Similarly, when m is 1, you are going to get C3 equal to minus 1 minus alpha. Oh, sorry. I'm sorry. Now m is 1, so it's going to be minus alpha minus 1 into, so I'm sorry again. M is 1, so it's going to be alpha plus 2. ये आएगा ना? Upon 2 into 3, C1. Is that okay?
Yes, ma'am.
Similarly, what will be C4 now when you put m equal to 2? You're going to get C4. So m equal to 2 would mean minus alpha minus 2 into alpha plus 3 upon m is 2. So 3 into 4, C2. But how much was C2? So that means it will now become, C2 was minus of alpha into alpha plus 1 upon 1 into 2. So that means minus minus will become plus, and it will have alpha, alpha minus 2, alpha plus 1, alpha plus 3 upon 1 into 2 into 3 into 4, C0. Is that okay?
Yes, ma'am.
Of course, the denominator is now 4 factorial, definitely, right? Similarly, when m equal to 3, you're going to get C5. And how much will be C5? M is 3. So it will be alpha minus 3 into alpha plus 4 upon 4 into 5, C1. No, sorry, C3. I'm sorry. And how much is C3? You substitute. So what do you get your C5 to be? How much is C3? Alpha minus 1, alpha plus 2. So it will be alpha minus 1, alpha minus 3, alpha plus 2, alpha plus 4 upon 2 into 3 into 4 into 5, C1. Can you write C6 by looking at C4? What should be C6? You have C2 with you, you have C4 with you. Can you now directly write C6 without computing? And then cross-check. Will it be minus or plus?
Minus.
Minus. Fine. Now, C4 started with alpha, ended with alpha minus 2. I mean, I'm just looking at the first two terms because their behavior and the behavior of these two terms can be generalized. You know? So, starting with alpha minus 2, what should be the next term?
Alpha minus 4.
Alpha minus 4, right? Then what for these plus terms, it's starting with alpha plus 1, and what should be the next term is alpha plus 3. So what should I have? The
Alpha
next
plus
term,
5.
Plus 5.
alpha plus 5. Fine. Upon
6 factorial.
6 factorial C naught. Is this okay? Similarly, can you write your C7 now? Again, C7 will be plus or minus?
Minus.
Minus. And how will it start? Alpha minus 1? Yeah. So it should be alpha minus 1, alpha minus 3. What will be the next term? Alpha minus 5. Then alpha plus 2, alpha plus 4, alpha plus 6 upon what? 7 factorial C1. Is this okay or not?
Yes, ma'am.
And so on and so forth. We're going to get things like this, right? Now, let's try to write the complete solution. One thing is very clear. Now my complete solution is going to be C0 y1x plus C1 y2x. Yahi aayega na? Because I have terms with C0 and I have terms with C1. Is that right?
Yes, ma'am.
Yes, ma'am.
Right. Then again, I observe that with C0, I have all odd even terms. Hey, Yorana? See, starting from here, C2 is in terms of C0, C4 is in terms of C0, C6 is in terms of C0. So that means starting with C0, I'm going to get all my even terms, and starting with C1, I'm going to get all my odd terms. That is also clear, right? So basically, if I just write my yx, it should be, see, what was my series? My series was summation Cmxm, m from 0 to infinity, which is actually nothing but C0 plus C1x plus C2x square plus C3x cube, and so on and so forth. This was my series, right? So basically, your yx is now going to be C0 into C0 will remain C0. I have taken common, so it will be 1. Then I have to write my C1. But what was C1? Minus, sorry, C1 is different. I'm sorry. So I'm writing C0 into something plus C1 into something. So the first term will be C, with C1, it will be X. Now comes C2, right? So how much was C2? Minus alpha plus 1 upon 2 factorial. यही था ना?
Yes, ma'am.
Into x square, right? Then plus C3x cube. So C3x cube will mean now C3. So it is in terms of C1. So it will go to the next bracket along with C1. So I'll have x minus, how much was C3? Minus alpha minus 1, alpha minus 2, alpha plus 2 upon 3 factorial x cube. Is that right? Then C4x4. Now C4 was again in terms of C0, but with a plus sign. So your C4 was what? Alpha, alpha minus 2, alpha plus 1, alpha plus 3 upon 4 factorial x to the power 4. Is this right? Similarly, x5 will now be again plus, but with C1. So it will be plus alpha minus 1, alpha minus 3, alpha plus 2, alpha plus 4 upon 5 factorial x to the power 5. Similarly, x6, C6 and C7, and so on and so forth. So this will be the term with C0, the infinite series with C0, and this will be the infinite series with C1. Is this clear?
Yes, ma'am.
You can write the next 2 terms also in your notebooks. I wanted everything to be on one page, so I do not have much space left here. But then write the next 2 terms. That means the coefficient for x6 and x7. We have already computed them. Okay? Now, that means I now have my y1x and I have now my y2x also. And we had seen that x equal to plus minus 1 were the 2 singular points, and we concluded that the radius of convergence has to be at least 1. Okay, so that means both y1x and y2x will definitely converge in this interval when x lies between minus 1 and plus 1, right? Because they were the 2 nearest singular points. Fine. Now, the thing is that this is the solution, the power series solutions that we have got, right? Now, what is so special about it? The obvious question should be, we have picked up a typical differential equation, we are solving it, so there must be something special about it. Okay, so that is what we are now going to find. What happens, to this power series solution for different values of alpha? See, alpha was any number greater than minus 1, right? And alpha defines what? Alpha defines the order of the Legendre equation, not the differential equation, the order of the Legendre equation. the order of the differential equation is still 2 because it's a second order differential equation. So one thing is very clear, Legendre's equation is a second order differential equation, but the order of the Legendre's equation is dependent upon alpha. Okay. Now with this as y1x, and so now let us do one thing. Let us write them separately. In the sense, let us write our y1x and y2x separately. So basically my y1x is actually nothing but 1 minus upon 2 factorial x square plus alpha into alpha minus 2, alpha plus 1, alpha plus 3 upon 4 factorial x to the power 4 minus alpha, alpha minus 2, alpha minus 4, alpha plus 1, alpha plus 3, alpha plus 5 upon 6 factorial x to the power 6, and so on and so forth. Is that okay? This is my y1x. And what is your y2x now? Y2x was actually nothing but x minus alpha minus 1, alpha plus 2 upon 3 factorial x cube. Please cross check alpha minus 1, alpha minus 3, alpha plus 2, alpha plus 4 upon 5 factorial x to the power 5 minus alpha minus 1, alpha minus 3, alpha minus 5, then alpha plus 2, alpha plus 4, alpha plus 6 upon 7 factorial x to the power 7, and so on and so forth. Is that okay now? So I've written my y1x and I have written my y2x separately, and we'll see how they behave when alpha takes on different values. Okay, now let's see. Alpha takes on different values means, see, we'll be bothered only about integral values. My alpha was any number greater than -1. Okay, so I'll start with the fact what happens when alpha is 0. When alpha is 0, what happens to both these solutions, y1x and y2x? What happens to y1x when alpha is 0?
Y1
Ma'am,
is
y1 is 1.
y1x is 1. Fine. But what happens to y2x when alpha is 0? It becomes x minus -1 into 2 upon 3 factorial x cube, है ना, plus -1 -3 2 4 upon 5 factorial x5, and so on and so forth. This is what you get. Is this okay or not?
Yes, ma'am.
Yes, ma'am.
Similarly, what happens when alpha is 1? What happens to y1x? When alpha is 1. Oh, sorry. What is y1x now? 1 minus 1 into 2 upon 2 factorial x square plus 1 into -1 into 2 into 5 upon 4 factorial x to the power 4 and so on and so forth. But what happens to y to x?
X.
X. Right. Now see, for alpha equal to 2, what happens to y1x? And y2x for alpha equal to 2.
1 minus
Hmm.
2 into 3 upon 2 factorial x square.
This is your y1x.
Yes, ma'am.
But what about y2x?
X minus
So it's still a
3
series?
upon 3.
Yeah. It's still a series? See, what is the difference between y1 and y2 here? When alpha is 0, I'm getting y1 to be a constant term. That means it's a polynomial of degree 0. For alpha equal to 1, I'm getting y2x as a polynomial of degree 1. For alpha equal to 2, again I am getting y1x as a polynomial of degree 2. But what is happening to the other things? They are still series. For alpha equal to 0, y2x is still a series. Similarly, for alpha equal to 1, y1x is still a series. For alpha equal to 2, y2x is still a series. Similarly, just see what happens when alpha is 3. What happens when alpha is 3? Hmm? What happens to that?
y1 is 1 minus 12 upon 2 factorial x square. 1 minus.
So that means basically y1x is still a series.
And then y2 is x minus
10
y2x,
6
upon 3
upon 3 factor.
yeah, yeah, x minus
2 into 5x cube by 3
10 upon
factorial.
3 factorial x cube.
2 into 5 by 3 factorial x cube.
X cube.
Yahi aa raha hai na? So that means what? Now I have a polynomial. What? When? When alpha is 3. Now, can you see the behavior? When alpha is even or when alpha is odd? What is happening when alpha is even?
Y1 is not the series.
Yeah.
It's a polynomial.
So when alpha is even, y1x is a polynomial. And what is the degree of those polynomials?
Ma'am, increasing that is 0, 1, 2, 3.
Is it odd or even? When no, no. When
Even.
alpha is even, when alpha is 2, y1x is a
Degree,
polynomial
so,
degree
ma'am,
2. So
even.
that means when alpha is even, y1x is a polynomial of even degree. But y2x is a series. But what happens when alpha is odd? y1x is a series. But y2x is a polynomial of odd degree. Is this okay or not? Hmm? That means whenever alpha takes, so see, we have just taken the integral values. Okay. Whenever alpha is an integral value or whenever alpha is an integer, okay, then what are we getting? Then one of the solutions of Legendre's equation is a polynomial. Is that right? So one of the solution of Legendre's equation is a polynomial. So this polynomial is called as a Legendre's polynomial. Okay. So depending upon which degree we are talking of, say for example, when alpha was 0, we got a constant term, right? So that, see, in fact, we denote Legendre's polynomial by these terms, P and X. Okay, so P stands for polynomial. So here, that's why we did not, that I told you, N has a different role to play in this. That's why we did not start with the power series as summation Cn xn. We started with Cm xm. So N here would stand for the degree of the Legendre's polynomial. And how can we find that? By giving different values to alpha. So when alpha was 0, we obtained P naught x as 1, right? Similarly, when alpha was 1, we are going to get P1x, and what was that? X. Similarly, when alpha was 2, we obtained P2x, which was what? P2x kitna aaya tha? Can you just go back and see? When alpha is 2.
1 minus 6 by 2 factorial x square.
Yeah. So it can be 1 minus Of course, this is along with C naughts and so on. So 1 minus 6 by 2 factorial. So I can write it as something like this. Similarly, P3x can be obtained, and so on and so forth. Okay. Now, these are called as Legendre's polynomial, but then what we are going to now do is again generalize the formula. I mean, every time we cannot be computing things. So what we need to do is we need to generalize a formula for P and X also. Okay. How do we write the general formula for P and X? See, what they have done is in the book, if you see, they have given the generalized formula for P and X as summation k from 0 to, I'm just writing it. I'll explain every term here and how we are going to derive it. Okay. 2n minus 2k factorial upon 2 to the power n k factorial, n minus k factorial, and n minus 2k factorial x to the power n minus 2k. Okay. Now see, your summation is varying from k. Okay. But it says capital N here. And what is capital N? Capital N is, we write it like this, n by 2, which means we are talking only the integral part of n by 2, because that depends upon whether n is odd or even, right? So if n is even, obviously n by 2 is an integer, but if n is odd, it is the integral part of n by 2. So basically, whether we write n by 2 or n minus 1 by 2, depending upon whether n is even or n is odd. So instead of writing like this, we can write like this also. So that means your summation has to, start from 0, but move up to n. And what is that? The integral part of n by 2. And what is small n? The degree that we are talking of. Okay. So n equal to 0, we are getting the constant polynomial. N equal to 1, we are getting a polynomial of degree 1. N equal to 2, we are going to get a polynomial degree of 2. Polynomial of degree 2, and so on and so forth. So once this formula is there with us, we can directly write the Legendre's polynomials. And if you just using this formula, if you just find the first 6 Legendre's polynomials and then plot them, you will see that they are going to be, functions. As you can see, starting first ka aa raha hai 1. So you have a straight line. Then y equal to x, you have line like this. Then gradually you are getting quadratic, cubic, fourth degree, fifth degree polynomial. So gradually what is happening? They are now becoming curves or waves. Okay. So this is a part of our, practical also, where we have to plot Legendre's polynomials and see. So when we do it in the lab, you will see how they behave, how the polynomials behave, starting from degree 0 to degree n. Okay. So far, we have not derived this formula as yet, but yes, we'll do it in the subsequent classes. Okay. So I'll just wind up the class right now because the time won't permit me to start